Good morning, afternoon, or evening to my favorite geometry class, or to whoever else may have stumbled across this YouTube video. Just some background information. This is in the middle of the panic over the coronavirus that happened in March of 2020. I'm truly really sorry for what's happened to you guys. You know, I really wish that this hadn't happened and you guys were able to go to school together and be with your friends while you're studying geometry and all your other subjects. But we can't change that, and what we can do is make sure we make the most of it and really try to make this class as enjoyable as possible for the remainder of the semester. And so that is what I intend to do. So let's go ahead and get started. This video is about the homework that I recently assigned on the constructions with your compass. And so today I'm just going to go over all of those and make it clear exactly how to do those constructions. So let me go ahead and get started. So this first one, number one, is to draw a line perpendicular through this point and to then create a bisector so that this line segment has been bisected. And so the way we're going to do that is we're going to set our compass to where the point and pencil touches the edges, and then we're going to draw half a circle or so, which goes through, which has that radius. And then we will do the same thing with our point at the other endpoint. And so we've created this strange elliptical shape, and I'll go ahead and fill in these points and get a straight edge out. And when I connect these dots, as long as I do a good job, it's done. We have created a bisector. This point is the exact midpoint between A and B. And here is my proof of that. For each of these, I want to make sure I show evidence as to why it's true. If you look, you can see that the distance from A to this top point is the same as the distance from B to this top point, which is the same as the distance from A to B. And so what we actually have here is an equilateral triangle. And so I'm going to go ahead and finish drawing the equilateral triangle. There's that. And this other point here. And there you go. It's an equilateral triangle. And actually, this line that goes down the middle turns this into a 30, 60, 90 right triangle. So, or two 30, 60, 90 right triangles rather. So you can see those are the two 30, 60, 90 right triangles right there. And yeah, we created our bisector. So for each of these, like I said, I want to show evidence as to why this works. So now we'll go ahead and do number two, which is to bisect an angle. So we have this angle that I just drew, or just some random angle, and we want to bisect it. And so the way you do that is you will put your point of your compass on the vertex of the angle. I'm gonna make it a little smaller actually. You can do whatever radius you like here. The radius is just the distance between the 2 points on the compass. So I'm going to actually go ahead and do this. Oops. You gotta make sure you keep your hands steady. It's one of the keys to this is to, you gotta be very careful to do it right. Okay, and so now we have this little semicircle going through it. And the point of that was to be able to label these 2 points right here, because that's gonna be important. Because now, of course, this distance here is the same as this distance here. And so we're not gonna change the radius, we're gonna keep it the same. So I'm always gonna make it clear if we change the radius or not. And we're gonna actually put our point here now. And draw another semicircle. Like so. Then we move our point to here. And draw another one. And now, so my evidence that this has worked is that we actually, we've created yet another equilateral triangle here, here, and here, right? And so now you can go ahead and label that point. And the last but not least step to be able to do is to connect the dots. And so I'm gonna try to do a good job. Ta-da! So this is a bisection of this angle. And again, part of the evidence is that if you drew this line, I'll actually draw all the lines. So if we draw this line, which connects from here to here, and then this one, I'm actually going to do it without the straight edge. I'm going to risk it just so that this video doesn't take forever. And there's the triangle. And so once again, we actually have this line which bisects this segment here. And so therefore it also bisects this angle. And you can see we actually have 2 equilateral triangles here that are reflections of one another. And these are all right angles here also. And this is a parallelogram. So a lot of really cool geometry all happens all at once. Okay, so the next part is to actually take a triangle and to copy it. And so there's 3 parts to that. So these are the numbers 3 through 5. They were all on page 171. Okay, and the first thing to do is to know how to copy a line segment. So I'm just gonna actually draw some random triangle, and this would work with any triangle. Doesn't matter what type, but I'm just gonna, there's a line, and there's a line. That actually looks pretty close to a right triangle. I didn't really mean to do that, but there's a line. So we have some random triangle. And I'll label the points A, B, and C. Okay. Now the idea here is to copy this triangle over here. And it doesn't matter if it's rotated or reflected or whatnot, but we just want to make sure we copy the exact same triangle. And so the first thing we're going to do is we're going to copy line segment AB. So the way we're going to do that is we're going to actually just draw a random line over here. Okay. And so here's our point, which is going to be A, the end point of this line. And then to make sure we get B correct, we'll take our compass and we'll measure just how far A and B are apart. So the answer to that question is that far, right? And so then I'll just come over here and draw a point on this line, which is exactly that far away. And we'll call that point B. call that point B. All right. And so then we also have this other point C that we need to have copied, right? And so this is the more challenging part because we need to make sure we get both the angles right and also get the rest of it right. So how can we do that? I'm gonna actually flip this paper upside down. It won't matter for the, okay, no, I don't like that. I don't like having the letters upside down. So we'll actually just keep it like this. Sorry, this shadow of, the way I have this set up is I have a large stack of books on the counter and then my phone is on top of all the books. So it's not a very stable setup here, but that's what I'm gonna do for this first video. Some of my videos, I actually have a whiteboard at my house. So some of them I'll be in the video at the whiteboard, and then sometimes I'll be here on a piece of paper. But anyway, let's continue. So the key here is we wanna make sure we get all the side lengths correct and the angles correct. And so the way we can do that is we're gonna measure how far is B and C apart from each other. And so the answer to that question is they are that far from each other. I want to get it just right. And so then I come over here to my new point B and I draw a semicircle, or like, you know, just an arc, a part of a circle right there. Okay. And so then I'm going to measure this distance from A to C, all right? And I will draw from point A another semicircle, which is going to intersect this other semicircle. And see, this point of intersection is actually going to be C. It's going to be C because, well, think about it. C is the only point, well, not the only point, but it is a point that is this far from A and it's this far from B. And so when we drew these semicircles, we made sure we chose a point C, which was this far from B and this far from A. And so then when I connect the dots, we will have exactly copied the triangle. And so this is actually the answer to number 5, is to copy a triangle, but number 3 and 4 is the same logic as copying a triangle, because if you can copy a triangle, you can most definitely copy an angle or a line segment, right? Copying the line segment was as simple as just measuring how far it was, drawing a random line, and then intersecting that line, the very first thing we did. So if you need to rewind the video and go make sure you understand how to copy a line segment, that's what we did first. And then to copy an angle, it's basically the same process of what we did throughout the rest of the video. We copied all 3 angles, right? Well, I'll just show very quickly. So I'm gonna draw a random angle. Ta-da! There's my angle, and I'm gonna copy it, right? I wanna make sure this angle right here, I wanna copy the exact same angle. So what I'm gonna do first, set my compass radius to where it goes through. Whoops, you can't ever let this point come off of the point that you want it to be on, otherwise it messes everything up. And that's what's really beautiful about this type of geometry that we're doing, is you have to be very cautious and meticulous about every movement. And I think it really teaches you certain disciplines that a lot of ancient men were better at us than we are, where we get everything so quickly, right? It can be very frustrating to slowly do something that a computer can do in just 10 seconds. But it's actually good for you. Okay, and these are a lot of fun, especially. At the end of the video, I'm going to show you some cool constructions I was working on just for fun earlier, and I think you guys will enjoy it. So, now we're going to copy this angle. To do that, we need to make sure, so we're going to label these 2 points. And when we come over here to draw a new version, the first thing we need to do is copy this line segment, which we already know how to do, hopefully. So we just, first of all, draw some random line. And we'll call this, so let me label all our points to make this simpler. We have A, B, and C. This is that pencil that one of you tried to take the other day. Okay, let's see. So this will be point A. Okay, so now what we're gonna do is keep our radius the same. And look, that tells us exactly where that new point needs to be, right? Because I kept it the same. So I do this. Now, while I do this, some of you may be wondering, why do this? You know, we have protractors. We can just use a protractor. Well, that's true. We could use a protractor, but this is actually proven to be more accurate. It's more accurate because this doesn't change, whereas with a protractor, you're kind of having to guess. Oh, it looks like it's about 37.5, right? Well, there's no guessing here. Okay, so then what we're gonna do is I wanna know how far away are the original points B and C. And so they look pretty close to the same distance, but I need to change it just a tad. And then we want to take it over here, okay? And we want to know, there's that, right? So all I did here was I drew an arc from this point that is the same distance as B to C, right? And the idea is now I want to know how far apart A and B are. And they are, oh shoot, I've forgotten if I was copying point B first or point C first. I think I was copying point B. Let's see, what was I copying? That's that far. Well, it doesn't matter because they actually are the same distance, right? So it doesn't matter. So now what we're gonna do, so we've made sure that this distance is correct. Now I just need to make sure this distance is correct. And like I said, they're the same distance. So now all I have to do is draw yet another point from here. And then this, which actually, this intersection here is going to be an exact copy of the same angle. Why did I start whispering? I don't know. Okay, here we go. Okay, and so this angle is actually the exact same angle. If you did this process and you took your protractor, you would be able to measure and say, hey, they are the same angle. And the point is that it's all about this radius, right? If the radii are the same in both, right, it has to do with equilateral triangles. It just works out. That's how these proofs work. Okay, just a few more. 6, 7, and 8. Let's see, what is the next one I have to do? Construction number 6, which is on page 213. Oh yes, construct a perpendicular. Now we've already done this first one, which constructed a perpendicular, but that happens to be the midpoint of our line segment. Now the question is, can we just take some arbitrary line segment and then some random point over here and figure out how to make a perpendicular that goes through this point and is perpendicular to this line, which we'll call AB, and we'll call our random point P. Okay, what do we do? Well, first, let's take point P and let's make a circle which goes through line AB at some point, and it also would cross it again somewhere over here if we extend the line. So I'm actually going to go ahead and do that now. I'm going to extend the line. And now the cool thing is we've created 2 points here that are equidistant from P. And so now we're in business to create our perpendicular. So what we're going to do is set our compass radius to equal these 2 points here. And I hope I have enough room on the paper. No, I'm running off the edge. Okay, that's okay. We'll just have to come and do it over here on under here. So we'll draw a semicircle. And then another one. And this point of intersection here, if we draw a straight line that goes through P and through this point and through our line segment here, it will actually be perpendicular. So let's do that. And there we go. And hopefully this looks like it is, in fact, 90-degree angles. Okay, what's the logic here? Well, whenever we originally put our compass and made this first circle, right, we actually now made we made a midpoint, right? There is some midpoint now of this line segment, and P is in a line with that midpoint. And it just so happened to go through A, but you could have put any P anywhere on this paper and you could have done the exact same thing. You just would have had to extend your line. You can actually also do this with a point that's already on the circle, right? A point that's already on the circle. Let's say I want to make another perpendicular line right here that goes through this point. What can we do? Well, first we draw another semicircle with any radius. My hand's blocking the camera, I apologize. But all I'm doing is taking this point that and drawing a circle around it. So and so you get these 2 points. Now let me actually make sure that they're all lined up. There's one point, and there's our other point, right? And this point is the midpoint of the 2 points. And then from there, it's very simple to just go ahead and do what we normally do that we did back in construction number 1. So I'm not gonna actually go through the steps, right? But you basically make the little cross somewhere over here, draw your line through it, and it'll be perpendicular. If you have any questions on that, you can let me know, but I already went over that. Okay. Construction number 7 on page 225. Ooh, okay, this one is pretty fun. So now we're trying to make a line that's parallel to another line. do that. So first I'll just take a random line. And that's what's cool about all these. You can do it with any line or anything you want to do it with. So here is our nice line, and we have some other point over here. It could have been anywhere, but I'm just putting it here. And we want to make a line that is parallel to this line, which goes through this point. And so the first step is to actually draw a line from some point along this curve. It doesn't really matter where. And we're going to connect the 2 points. And if at any point you see where this is going and you want to try it yourself, if you were stuck on the homework, feel free to try to do it yourself. So again, what we're trying to do is make a line parallel that goes through this point. And so what we're going to do is we're going to measure how far is this, right? How far is this? Okay, and it is that far, right? And so then what we're going to do, and this step might not seem clear, I'm going to extend this line, and I'm going to do it yet again. Look at that, left-handed. And there's that new segment. All right. Now, part of the logic here is because there's equidistance. And so we're going to extend this line yet again to go through our new point. Right. And I love these constructions because it seems like you don't know where it's going, and then all of a sudden, boom, you're like, ah. So that's what we're trying to do. Like, you might say, like, well, what was the point of that? Well, now what we're going to do is we're going to pick this other point on this line, right? I have my point on here. Do it with my left hand so I'm not in the way. Pick this other point over here and draw another semicircle. Okay. Now, however far this point is from here, okay, right, we make a triangle. That's how far this new point in our line that's going to be parallel to this line needs to be from here, right? So let me make that clear. We have this line, and however far this distance is from, if this is point A to point P, well, there's going to be some other point over here that needs to be that distance from this point. And so since we already have our compass set, well, we don't have it set like that yet. So I'm going to set the distance in our compass from A to P. All right, can you still see? No, let's change this. Ta-da, oh, yep. So we have the right distance, and then we're going to come over here and draw a point of intersection. There. So it's the same distance, and let's do the grand finale. Draw a line. Okay, that doesn't look parallel, so let me make sure I got my measurements right. Whatever distance this is from here to here. Ah, okay. So my distance from A to P isn't matching. So what we're going to need to do is actually put this point A. Sorry, I messed up, guys. I might go back and edit this. We have this point here. Yeah. All right. And now those 2 points are equidistant from each other. That's what we needed to do. So now when I draw this new curve, oh wait, we already drew that curve. But when I come over here and draw this curve, it's not gonna be in the exact same spot. See, they met just a hair over, and that hair is gonna make all the difference to making these lines actually look parallel. And there we go. These two lines are parallel. So again, the idea was to make this triangle and then basically copy the triangle over here, right? So let's actually draw the triangles that we made, because we actually just took a triangle and then slid it over down the line, right? And this is actually a really cool way to make a trapezoid too. That's what another thing I love about all these constructions. You find little neat shapes, right? If we actually connect these dots now, we made three equilateral triangles that together made a trapezoid. Would you look at that? There it is. Right, you see the trapezoid, you see the three equilateral triangles, right? 60, 60, 60, that's 180, right? All these angles are gonna add up to 360 because it's a quadrilateral. All right, and we can count to make sure, 60, 60, 60. Of course, it will add up. You can count it yourself. So, and if we wanted to, we could put another point here, and we could just keep making a bunch of equilateral triangles, and we can make any kind of design with them we want. We can make a hexagon or whatever you want to do. So with these constructions, you can always feel free to play around after you finish. Okay, one more, and I remember what this one is, so I don't need to look at the book. We are just gonna take a line, so here's our line, and then take some random point, and we want to reflect this point across the line. Okay, we want to reflect it. And so let's actually up the game here. Let's reflect an entire line segment. I want to make this more fun because this will also make a cool trapezoid. Now, so our goal is to take this little line segment and reflect it across this line. So it's going to look something like this. It's going to be something over here. How do we do it correctly? Well, the first step, we're going to measure how far we're talking here. All right. So that's how far it is from the line. No, let's make this a little bit more accurate. What we're gonna do is we're gonna expand this out a little bit so that we can draw 2 points and find an actual midpoint. So I'm blocking it again. I gotta get better at doing it left-handed because I don't block it when I do it left-handed. Let's give it a left-handed go. Oh goodness. Boom. So now I'm going to go ahead and extend the line a little bit because it didn't quite match. Okay, and the point of doing that is because now we have these 2 points, which are the midpoints. Right? If we take the midpoint here, right? Let's go ahead and do that, just like we already know how to do. So we're going to set our compass equal to the length of these 2 points. Move the ruler. And draw part of a circle. Can't really see it. I drew this little section of a circle right here. It's boring. Okay. Then I'll draw this one. Did not expect this video to last so long. And now, wait a second. We do need to make sure also that these distances are equal. So it's all nice and good that we did it there, but what we should have done is set the radius equal to this, right? Because look, if I try to draw this line, that's not a reflection. It would be way over there. So instead, and I apologize, extending the length of the video because I'm making a mistake, we need to draw. So we have that distance here now. So now we need to go over here. Draw that semicircle. And this one. Now we're in business. And then we have this new point here. And that one is a reflection. And we're going to do the same thing with this point. So I'll go quicker this time. You just basically figure out how far. We'll know, first of all, we do need to make a little semicircle. Through this point. Why? What the heck was that for? Well, we do that so that we have 2 points which, if we drew a line perpendicular here, it creates this it's not a 30, 60, 90 in this case. It is a we have two 90 degrees. It just depends on these angles. We don't know what these angles are. But what we do have is a situation where, let me finish drawing it and then you'll see. All right, so now we set the distance equal to these 2 points from here to here. Wait, I meant these 2 points. It gets confusing with all these extra points. This point was the one that went with this one. Let me make that clear. This point was the one that went with this one. This new point is the one we just drew. So I should measure it to be that length here. And I apologize for the quality of this video. I know that I will improve as we do this more. Okay. Now I'll come over here and do the same thing with this point. And what it does is, again, it creates this point here that is equidistant from here to here. And this is also equidistant from here to here. So it creates this mirror like we want. So there is our point. And last but not least, we will connect the dots. And there you have it. We reflected this line segment across here. If we connect these lines, and I apologize for not using a straight edge, I'm just trying to keep this video at a viewable length, we created another trapezoid. So that's fun. Now, before we go, I want to show you something I've been working on. Oh, it only took a few minutes actually. Is this really cool drawing I made with the compass? So this looks a little bit like a sand dollar or a flower. And yeah, and so my challenge for you guys, I should erase this little point here. My challenge for you guys is try to figure out how to do this, make this cool drawing. And actually, something unique about this drawing, there's a lot you can study here. But one thing is, so you can see there's 6 points. 1, 2, 3, 4, 5, 6, which if we connect all those points, what happens is it forms a perfect regular hexagon. And so, let's see, this will take me a second. While I'm doing it, I'll try to come up with a good joke. What do you call cheese that is not yours? Nacho cheese. Okay. Almost done. And you can make these flowers to where they have more than just six petals. 6 petals is one of the easiest ones to make. All right, boom, there we go. We have a regular hexagon inscribed inside a circle and this little flower. So just wanted to show you guys that. Let's see, one more. Another thing I made. So this crazy picture that I made with a bunch of circles is a whole bunch of 30, 60, 90 right triangles. And it all started with that original construction we did on number 1. And I basically just drew a bunch of circles in different spots and I was able to make this rectangle. I haven't really studied anything to do with this rectangle, but I encourage you guys to take a look at it, see what unique properties you find. Okay, well that's it for this video, and I'm gonna put in the description, I'll put what I'm working on at a given point so that if, for example, you understood number 1 and you can skip through that, you can move on to number 2, etc. And I hope everyone has a great week. Oh, as far as turning in your constructions, I'll send that in an email. So, all right, have a good day.